We will now come to the next specialization topic in the Master Curriculum Technical Chemistry. And our next speaker is Professor Jürgen Fleig. He's professor for electrochemistry. Most of you will know him. He was Institute of the Head for Chemical Technologies and Analytics. And he will now talk about high performance. No, he will talk about physical chemistry and analytics. Yes? Okay. All right. Just a second. I need to find my cursor. All right. You want to use this? And you have to switch on the microphone.
Okay, so thank you very much. As Peter Gettner told you, I'm at the Institute of Chemical Technologies and Analytics, and actually our institute contributes to all of the masters a bit, so we have courses in all of them. However, in two of the masters we are strongly involved. One is carried completely by our institute, and that will be shown by Christian Giel. That's a high performance materials master, and then there's another one where we have a 50-50 activity of our institute and of the Materials Chemistry Institute. And that's what I'm talking about the mixed one, the master program with the specialization, applied physical and analytical chemistry. And applied really means it plays a big role how we use it, though it's clearly a master which is very much about the fundamentals of the things, keeping the application in mind, but looking at the fundamentals of physical chemistry, including theoretical chemistry and electrochemistry, that's me, as well as analytics with an emphasis of solids, but looking at the fundamentals of such things with a broad view also on the applications. So it's really about achieving the competence to synthesize, characterize, test, modify, tailor materials for different applications. And we really mean the whole field synthesis, though we are certainly not as fancy as you in the way of synthesizing material, but we have to prepare raw materials. The characterization is certainly the field where we are stronger than you. We have the big instruments, as you see here. And then properties applications, that's important for all of us to know what to do with things. Okay, about the courses. That's the mandatory part of the specialization. So these courses have to be taken by everybody choosing this course. And it's about, just going through it, it's about, fundamentals of physical chemistry with kinetics and catalysis and electrochemical energy conversion and energy storage. That's my own course. Then the properties of surfaces and solids with chemistry and physics of interfaces, physical and theoretical solid-state chemistry. And then we move to the analytics part. So that's more the physical chemistry part, and that's more the analytics part. Vibrational spectroscopy, separation techniques, surface and interface analysis, crystallography, and analysis of solid materials. And there's all the courses. We have mandatory lab courses. It's split into two parts, the physical chemistry part and analytics of surfaces, and the strongly analytical part and separation technologies. So that's the mandatory part, what you have to do when electing this specialization. And that's simply an overview of recommended modules. As you heard in the beginning, you have to choose either individual courses or also a couple of modules. Actually, you have all the modules you can choose. It's not said that somebody choosing a specialization has to choose from the specialization courses or modules. You can do whatever you want. However, there are certainly modules that are stronger related to a certain specialization than others. And these are the modules that are strongly related to this applied physical chemistry and analytical chemistry specialization. And it is, quickly going through it, physical and theoretical chemistry, again electrochemistry, materials chemistry, solid state ionics, mass spectrometry, that's the physical chemistry part, and that's again the analytics part, mass spectrometry, X-ray, structure analysis, environmental analysis, advanced spectroscopy, and electron microscopy. Most of them consist of simply 2 courses, some of them 3, but most of them have simply 2 courses. And then finally, we have 2 to 3 elective lab courses, which you have to do in the individual working groups. That, because the master is carried by 2 institutes, involves usually lab courses in both institutes. Okay, these lab courses, and especially the master thesis, are then mostly in the topic we have just presented, or I have just presented. So let's give you an idea on the specific topics of either lab courses or especially master thesis in these different research groups. And here we have some topics simply collected: energy conversion and storage, theoretical chemistry, pretty much about catalysis, because this is also partly catalysis, chemistry of the atmosphere, electrochemistry, and again the analytics part, elemental analytics, process monitoring, environmental analytics, and bio and polymer analytics. And to be a bit more specific, I will show a few examples. Well, the first is not really an example, it's again a bit an overview, because many activities are going on at the moment in these research groups, together with the Cluster of Excellence, FWF financed Cluster of Excellence, materials for energy conversion and energy storage. And here it's very much about green hydrogen. Actually making green hydrogen by either electrochemistry, electrocatalysis, or by photochemistry, photocatalysis. And when having the green hydrogen, you can use it either in fuel cells to get current again. Here it's much about catalysis. Or you use it in chemistry to prepare methanol, ammonia, even steel is a big topic at the moment. And here that's the other use of hydrogen. So pretty many activities are going on in this field. That's more the overview and a bit more specific. Here, for example, we have an example from the research group of Günter Rupprechter. And they are using in that example photo emission electron microscopy, one of those big instruments, to look, for example, at the activity of a rhodium catalyst depending on the orientation of the surface, and that are actually photoelectron emission images, work function images actually, where dark parts show that much oxygen is on the catalyst and it's therefore inactive, and other parts are active because little hydrogen and oxygen are on them. So it's really probing the catalysts for hydrogen oxidation. And that's how it changes, it changes in its activity, fluctuates. Okay, that's an example from electrochemistry, our own field. One example is solid oxide electrolysis cells, applying a voltage and then splitting water or steam into hydrogen and oxygen. And here we are very much active in investigating the catalytic reaction at the surface. And because this is a high temperature electrolysis cell, we investigate samples at high temperatures. First we prepare them, that's the synthesis part, but not as fancy as yours. We have pulsed laser deposition, pretty physical. So shooting a laser on a material and depositing it, making thin films, and then doing, for example, impedance spectroscopy to get information about the catalytic activities. Theoretical chemistry is also a pretty strong research activity. Here we have different topics. The quantum chemistry part is more solving Schrödinger's equation with more and more fancy methods and better approximations. Then recently, machine learning became really, really important for the theoretical chemists as an alternative approach to get information, and then applying both of them to a material's design, tailored properties, for example, thermal and electrical conductivities, and so on. So that's the theoretical chemistry part of our of this master, specialization of the master. Two other groups are working in catalysis. Noelia Barabes, that's more on nanocluster catalysis, and Karin Föttinger doing industrial catalysis, so again, pretty much on catalysis. And then we move more to the analytics part. Here we have the Forschungsgruppe, the research group of Grote, chemistry of the atmosphere, analyzing asphalt or microplastics, bioaerosols in the atmosphere, analytics of the atmosphere. Then we have the surface and trace analysis, chemometry. It's pretty much about material science, looking at materials, but also at life science issues. Research groups Limbeck, Hutter are working on this, and only mentioning a couple of methods: laser-induced breakdown spectroscopy, laser-induced inductive coupled plasma mass spectrometry, time of flight secondary ion mass spectrometry, and I'm pretty proud to having succeeded in knowing what the abbreviation means. Well, fancy methods, and the research groups of the analytics, they often work together with the other people more preparing the materials and looking at the properties. It's pretty nice having all these collaborations, and they optimize all these methods. For example, for detection of microplastics or for investigating diffusion experiments into diffusion of metals and such things. Then we have the process analytical chemistry, research group Lendl and Rama, pretty big activity. They are very much in optimizing the analytical tools. In their case, it's mid-IR laser spectroscopy, so they really do optimization of the analytics and applying it to environmental and process analytical topics, also materials characterization. It's much about lasers and lots of activities with company partners. And finally, an example that already bridges a bit the next one. It's it's the bioanalytics, lipids in lung, proteins in Alzheimer brains, and so on. It's about the Forschungsgruppen Brunner Grünberg and Marchetti Deschmann, also contributing to analytics to this master, but probably more to the next one in the bioanalytics and biotechnology. Okay. Summarizing, what you get in this specialization is a sound atomistic molecular understanding that hopefully allows you solving physicochemical and analytical tasks. It's certainly very highly relevant in many different fields of technology and economy and society, and therefore also a broad range of professional activities is accessible. If you are interested in that, just come in and find out. Thank you.
Thank you, Jürgen, also for your nice presentation. And as is said here, come in and find out. I did not mention that before, but in the afternoon you will have the possibility to visit all the research groups. Yeah? We have times scheduled at 1, 2, and 3 p.m. Where you can meet in front of the porter's office or the BA building, and people will pick you up there and show you what we are really doing at our research groups, and you can have a look at these groups as well. So thank you, Jürgen. Yeah, and of course, I mean, we are recording these presentations, and they will be available on the Dean's Office web page. And whenever you have a question afterwards, you can contact, of course, everybody here, and we will be happy to answer your questions.